Hello, hello. Welcome to Physics 114 at the College of Staten Island, Introduction to Physics. It is a general education course, but primarily fulfills the requirement in physics for students who wish to get a degree in nursing. Hi, so glad you're here. Very, very happy to have you in class. Now, many people aren't really quite sure why nursing students should take physics. The answer is all nursing is basically physics. I mean, sure, there's some chemistry and some biology and everything like that. But a lot of people don't realize until it's too late that physics is the thing that distinguishes a good nurse from a great one. It is true. A lot of people don't see that. And you know what? I blame us. I blame most physics curricula. All right. Physics professors, generally speaking, including me, um, we have good intentions. We want you to learn good stuff because we know how valuable it can be to you. However, we don't do a good job conveying it sometimes because we kind of forget what's important when it comes to physics. What is physics anyway? It's really a system where we learn how the universe works, in repeatable ways, in ways that make sense, things that we see in life all the time, right? If I throw a football or if I lift something with my arms, that's all physics. And our brains are really good at it. And if we use that knowledge wisely, then we're really, really helping ourselves out, both career wise and life wise and everything like that. Problem is, we have to write it in terms that sometimes make it harder to understand because physics is so fundamental that we use a lot of math. We use a lot of conceptual ideas that sometimes seem foreign to us, even though they're just as natural as walking down the street or putting a pot of water on or taking somebody's pulse. That's all physics. Now, why is it so difficult? Well, part of it, again, I blame the educational system that produces a way to do physics in a way that makes it a little bit scary, makes it feel like it's an obstacle, right? Only smart people can do it. No, you are smart enough to do physics. All of you are smart enough to do physics. And if you believe in yourself, I am confident that you will do very well in this class, not necessarily because you're a math whiz or not necessarily because you're a physics whiz or a science whiz, but because this is plain old common sense. It's good knowledge that's got like details to it that you might not think about on a regular basis. But in the end, it's about this thing hitting that thing, or this thing pushing that thing lighting up that other thing. These are things that we are really good at as human beings. And it's just a matter of learning how to write them down, learning how to express them, and learning how to reproduce them in things like machinery, right? Whether it's our cell phones or whether it's a defibrillator or in some sort of devices. It could be something for our hearts. It could be something for our brains. It could be eyeglasses. All these kinds of very simple things that make all the difference. If you take this physics class and as a result understand the right way to lift someone out of bed or the right things to look for in blood pressure or to do those kinds of this and that and like how you filter things or how you move things back and forth, breathing, blood, those kinds of things, you will be that great nurse. Right? That's just how it goes. I will tell you one last little thing, then we'll jump onto the transcript. Not transcript, the syllabus and things like that. So that's the kind of thing you want to know for the first lecture, right? So this is all important stuff. But I have a nurse friend who is currently very successful in New York. She runs a clinic. She does kidney stuff. She makes more money than I do. Okay, and when she heard that I was making this class online asynchronous with these lectures about how we're going to learn physics. She's like, absolutely. Everything I do today is physics. I'm like, really? Not chemistry, not biology. She's like, nah, that stuff is like useful. Yes. But when it comes down to like, what am I going to push into somebody? What size syringe am I going to use? Is this something that mimics the kidney or something that mimics some other organ? Is it phoresis? Is it dialysis? How does it all work? It's all fluid physics, man. Right. And that's just an example of the kind of value you can get out of this class. So take that to heart, okay? Realize that this is not like hard stuff. You might have a mental block to it, and I apologize if you have, because it's like our fault, like I said. Like very often we are stressed out about things like math and science. Really, though, it's just a way, a language, an expression, a way to talk about things in sentences using symbols that we might not understand. But many of you speak foreign languages, for example, right? Some of you may speak Chinese, or you may speak Russian, or you may speak Swahili, um, all these other things. These kinds of languages, they often have different alphabets. They have different symbols. I mean, even something like French and Spanish or German, they've got like weird symbols or little curly cues or double dots over their letters and so forth, and they mean different things, right? But those kinds of variations sometimes create a barrier to our understanding, right? But they're not inherently hard. Like I could not read, say, a billboard that was written in Cyrillic. I can read a billboard that's written in Chinese, right? Now, does that mean that like somehow my brain is better for Chinese, or that that somehow I can't learn Russian or Cyrillic, anything with a Cyrillic alphabet? No, all it is what I'm used to and what I've learned. Right? There are 3-year-olds who speak Russian just fine. There are 3-year-olds who speak Chinese just fine. There are 3-year-olds who speak English just fine. We just have to find our voice in those languages. And I don't expect you to become super math genius just for this class, or super physics genius just for this class. If you appreciate it and understand it, that is what I'm looking for. And I hope we'll have this journey together and really learn the physics that is valuable to you and to all of us as you embark on your careers, whether it be in nursing or in something else. I really look forward to seeing that. And I really look forward to you getting that understanding about how the universe, how the world, how the human body at its most fundamental level works. Okay. I got to go somewhere. I will be right back. Okay. Hang on. Hi, I'm back. Obviously, you didn't have any delay, and that's actually going to happen every once in a while. This particular lecture series, these 24 lectures that comprise the video lecture series for Physics 114, not exactly high production value. It's one guy in front of a camera, right? That's okay, because what I'm doing is knitting together a curriculum for you that makes sense, right? Something that you can use. And so what I display is not as important as the kinds of things I can convey for you to go look at other stuff. In other words, I may be low production value, but it's high in content and organization. Meanwhile, there are many other people who have done some great stuff with high production values, which we will learn from, which we will use and accept their kind generosity in producing this material for us. We look forward to using them. Be ready for that. And that's how we're going to do this whole course. Okay, so I'm going to start showing you some stuff. I'm going to share some screens so you get some sense of the syllabus and the study guides and things like that. And you can see what's going on. Okay, here's Physics 114. And the first thing you'll see is that there is online asynchronous lectures. That's these things here. This is lecture 1 out of 24. Synchronous recitation sections, which means that you have the opportunity to talk with a person in real time online that will not only help you learn the material and be like more effective in your physics work, but also give you the chance to earn substantial bonus points for your final exam grade. That's cool. And then there's the in-person laboratory class. That's when you're going to the College of Staten Island and you're actually going to go do stuff with your hands. Okay, so that's all important, and make sure to be involved with all of it. So here's the course learning objectives. You want to be able to describe, first of all, what the heck a scientific theory is. A lot of people think that physics and chemistry and biology is just a whole bunch of facts put in a big book by people in white lab coats, and you're supposed to memorize them and regurgitate them on some exam and forget all about it. That is not actually how science works. And you know, I don't want to be too haughty about this, but there are some people who have said over the years, like, for the past centuries or so, that basically a lot of physics is true science, and the rest of science is just stamp collecting. So you're memorizing a lot of stuff, but physics concepts are what matters, right? Equations that describe things that matter on how the world, how the universe, how the human body works. These are the things that you're trying to learn. So you kind of need to know what a scientific theory is. You better distinguish it between scientific, non-scientific, and pseudoscientific knowledge. This is the vast majority of the material in lecture 2, which is coming up after lecture 1. Okay. And then meanwhile, make sure you learn the basic fundamental laws about human activity and healthcare. And then the lab component, really important, everybody. Conduct the scientific analysis of physical science data, make relevant calculations, do measurements, things like that, that allow you to really see you don't have to be a rocket scientist or anything to really know or get a sense of how things work. It's really cool. And I want you to get some of that joy. I mean, it seems simple, like you knock a couple of balls together, or you slide this that way, you slide that way. It seems like silly, but actually, it's the deepest part. It's the most fundamental and significant stuff when it comes to the motion and the matter and the energy that binds us all together, that moves us all around, that causes us to be who we are and what we are. So it's really important, okay, this is something I'll jump into right away, that you understand the concept of academic integrity and support. Now, I'm going to stop sharing screen for just a second because I just want to look you in the eye and tell you this honestly for me. I really don't care nearly as much about whether or not you get answers correct as whether or not you attempt them. Okay, I would love for you to get the answers correct. And if you get the answers all right, wonderful. But that means a secondary value to me. What matters primarily is that you tried to learn it and tried to understand it. I mean, think about if you're going to, like we're using the previous example, right? Let's say I go somewhere that speaks Russian. All right, this is the Russian language is going on there, or something like that, or Polish language, or something like that. I don't care. It doesn't matter. Spanish language. I don't speak Spanish all that well. And I get off the airplane or something, and I'm like lost, right? But if over time I keep trying and I learn, I use my various tools, I read, I watch, I listen. Over time, I might be able to find out where bathrooms are, right? Eventually, I might be able to read a newspaper. And then after some period of time, I might be able to get a joke, things like that. That process of learning is where you are right now, right? Like I said before, I do not expect you to become magically awesome physics students or magically awesome math students. It'd be great if you did. And if you're already strong in those things, all right, more power to you. You and me, we'll go hang out. This is a great thing. All right. But what's important is that you make that effort. And so as a result, the effort matters so much that you need to tell me that it's your effort, right? Like I said, great if you get the right answer, but it matters more to me if you put the effort in or not. And that's why the honor statements are so important. You got to handwrite them, and you have to videotape them. You have to really follow them. The homework acceptance system can actually figure out, for example, if you've cut and paste any answers from one place to another, and even figure out if you've cut and paste your own work, things like that. There's a lot of things that it can do. And the main point is just do your own work. I don't care nearly as much if you get it right or wrong as if you've done it and if you've made the effort. So keep that in mind. And this is a key for academic integrity. All of the work that you do. In the nursing profession, I would much rather have somebody be my nurse that I know who was learning stuff on their own and maybe didn't get everything exactly right, but really internalized and had knowledge that they gained as opposed to, just sort of stuff that they copied from somewhere. Don't you think? I would. I want you to be that way too. So feel good about wherever you are and what you do. And that's the key point. If you ever have any troubles or challenges, you should always talk to me. You should always talk to your recitation instructor, talk to your lab instructor. There's a lot of that going on, and you should always feel comfortable talking to your professors. You should always contact me. Now, make sure you contact me, I'll just say this right now, at this email address, charles.liu, L-I-U, at csi.cuny.edu. You'll be turning in assignments on a different email address. But this is the one that will actually reach me, that I'll actually see more readily. I'll still miss emails, but I'll see these here. If you send it to that other email address on the message, other than what you're turning in assignment-wise, I may not see it for days or weeks. So this is the email that you send stuff to, okay? And then there's also, like I said, your recitation instructor and your lab instructor. So make sure you contact them and be in touch with them as well. Does that make sense? Okay, all right, back to the sharing of the screen. And so really take this seriously. Take this to heart, the honor statement and all the kinds of things that this matters. It really, really does. And so if you fail to turn in the honor statements, or if you fail to fulfill the terms of the honor statement, then you earn a failing grade for the course, because that's not how we wind up doing stuff in academia. That's not how you succeed, right? We want you to own whatever you get. And that's the important part. All right. Yes, there are people who will get by in life by cutting corners or doing things that are outside the rules. But if you're not one of those people, you can hold your head up high and you will know that I will want to see you, not that other guy. Right. That's kind of how it goes. So now the next aspect is also very important, but the course is asynchronous, right? That means that aside from the labs that you must go to on a daily basis, right, whenever it meets, and the recitation sections, which you come and visit as described here in this section, right? They're you on your own. You do whatever times you want. So they really have to be on time. All right. If something is due on a Sunday night, right? Don't wait till Sunday night to start doing it and then realize, oh my gosh, I don't have time. I can't get this done. All right. Do it on Saturday. Do it on Friday. Plan ahead. Get this done well ahead of time so that everything is smooth going forward. You have everything there. You're ready to go. In fact, all the content, all the study guides and so forth are already posted on Blackboard. So you can download them immediately. Not that you want to do the entire course in the first week or anything like that, but the opportunity exists for you to be able to be as far ahead or behind as you wish, hopefully ahead. All right. And make sure you keep those due dates in mind. If you don't turn them in on time, you will not receive credit for them. Right. I mean, really, I don't want that to happen. Just keep this as part of your learning in this course, being on time, being responsible, being synchronously able to do those due dates. Okay. Really, really, really important. Okay. Now, this is the recitations. And if you can read this, you can see that you can earn, for example, up to 30% of your final exam project points in advance. Wouldn't that be nice? That you could score the maximum points on your final exam, which is like 25% of your grade or something like that. And you've already gotten 30%. You only need to score 70 out of 100 to get maximum points. Would that be cool? That is what you can earn if you're attending the synchronous online recitation sections. Okay, and that is something that you should talk with your recitation section advisor, professor, who may already have been in touch with you through Blackboard. All right, so it's really, really important. It's not required, but it's to your massive benefit to participate. All right, and find ways to participate or to talk to the recitation professor and so forth and have those conversations as soon as you're able. That's really, really valuable. Okay, so the online lectures, as I said, when you read them and you do them, right, you should take notes. But there's other online materials that will be woven in to the lecture notes, to the study guides that you have to turn in, one for each lecture, including this one, right? I'm going to show you one of those in just a moment, but that's basically what you have to do. And here is the syllabus of the material, right? These are overlapping topics, but overall you get a sense of what physics matters. First part, physics in general as a science, right? Part two, physics of the four primary vital signs. If you are a nursing student, or if you're a nurse, my friend nurse who runs that kidney thing up in Manhattan, right? I asked her, what are the physics of the, what are the four primary vital signs? She's like pulse, blood pressure, respiration, temperature. I'm like, wow, right? Meanwhile, my wife, who is a PhD mathematician, right? She can run circles around me in terms of all kinds of amazing mathematical theories. She's like, I didn't know that, right? So it's all what we're expert in. And if you know how the physics of the four primary vital signs work, you're already way ahead of the game when it comes to nursing, right? When it comes to doing healthcare stuff, it is a generally positive, awesome thing. Then finally, the idea of the human senses, right? How does your brain work? How come we can touch things and sense them? How do your eyes work? How do your ears work? How does life work? Right? There's lots and lots of great stuff in all that, and it's all physics. Yes, there's some chemistry. Yes, there's some biology, but in the end, fundamentally, it's physics. So it's worth learning because that puts you in a category of nursing and human excellence. If you have worked on this, if you've worked, made it happen, just do it. I gotta tell you. All right, I'm gonna pause again. I gotta tell you something very, very important. Studies have shown, and I was amazed when I saw this, but it's absolutely true. If you have taken courses in physics and the sciences and liked them, it doesn't even matter how well you did on them, as long as you like them and appreciate technology. On average, your lifetime earnings will be double that of someone who has the same credentials as you education-wise, but doesn't like math and science, doesn't appreciate math and science. Isn't that amazing? It's really true. I have all kinds of examples to tell you, like people who have that kind of experience in their lives. I don't want to use this particular lecture, but we're always happy to talk about it later if you want to. So appreciate the science, have an open mind, and you will benefit richly on average. Okay, gotta be earnest about that. Got to do the statistics and everything right. Anyway, here we go. The formulae here, right? These are just sentences, but instead of written in English, these symbols represent different things. And over the course of the class, you will find out what most of these things mean. You might not use all of them. You might use some that aren't expressed here, but generally speaking, if you understand these key formulae, okay, if you know how to use them, if you know what they stand for, right? This P over here, P equals FA, is not the same as this P over I here on this equation here, right? It's different from this lowercase p over here, which is M times V. But this lowercase p here is the same as that lowercase p over here in R cross P. Wow, it seems like a riddle, but it's not. It's just a matter of expression. I mean, think about the sentence that we're reading here, right? There's a letter A over here, and there's a letter A over here, and there's a letter A over here. And somehow, even though they're all the same letter A, they mean different things because they're in different words, right? It's that kind of thing. It's not mysterious. It's not scary. It's just something you're not used to. And I want you to understand that and really feel okay about not knowing exactly yet. All right, now, the online asynchronous lectures and study guides, these are the core of the course. If you do these, okay, and if you do them well, do them conscientiously, then you're essentially guaranteed to pass the course as long as you do all the laboratory assignments. I mean, it's really kind of how it goes, but it's really, really important that you do them, okay? And I'll give you an example. I'll show you what it looks like later on. Meanwhile, laboratory assignments. This is really kind of important. Labs are the single largest part of your course grade. Okay. And I don't assign the lab grades. The lab instructor assigns your lab grades. So you really have to pay attention to it. And as it says in italics here, if you don't earn a passing grade for the lab, you'll earn a failing final grade for the course, regardless of how you perform in the other stuff. Why is that? Why is lab so important? I think it makes sense if you think about it. If you're going to be a healthcare professional, can you just point to the person and say, okay, you do that now? Right? You actually have to do stuff. You have to move things around. You know how things work and how things move. All these things matter in terms of your touch and your manually working with them, things like that, right? Your hands, your eyes, your senses, all of this matters. So that's why the lab is so important. And it's really, really, really important that you take it seriously. Okay, remember, I do not assign the lab grades. So that you have to work very carefully with lab instructor, make sure you fulfill all those requirements as effectively and conscientiously as possible. And then we have talked already about the exams in the project. The midterm exam is not a whole lot, right? It's 5, 10%, something like that of your overall grade. But then the final exam project is larger, okay? But if you wind up doing the recitation sections, you give yourself a big head start on the final exam grade. And that benefits you tremendously when it comes to the grade for the course, right? I think is really, really good. Okay, finally, this course completion policy is really, really, really important. Okay, the asynchronous lecture structure of the class means that you really have to pay attention to all the deadlines. If you don't do these things, then the grade is F. All right, you've earned a grade of F. You really have to use this class as an opportunity to hone your organizational skills. If something is due on Sunday, start it on Friday. You know, set yourself goals, pace yourself. Don't wait for everything till the very end. I will occasionally give extensions, but generally speaking, you take a big penalty on them unless it's something really significant. Sometimes things happen. I understand that, but you got to let me know well ahead of time. As soon as something comes to be a problem, you have to let me know. And once again, the email address, right? I know I'm small in the corner, but it's charles.liu@csi.cuny.edu. Make sure to contact me. Make sure to contact your recitation instructor and your lab instructor. All of us need to know what's going on so that we can be of assistance. Okay, sound good? All right, so here's an example of a study guide that you might wind up doing. Yes, indeed. You should read through the study guide first before you start watching the lecture video. Did you do that? Nah, I bet you didn't. But you know what? You can start now. From here on and on every other lecture, before you watch the lecture video, read the study guide assignment sheet. This is a classic strategy so that you know what you want to pick up and what you want to learn. You must handwrite the honor statement right at the very beginning, hand sign it, hand date it. Okay, and then you're filling out all these things by hand. I'm telling you to hand write your answers. Why? You may already know this. Studies have shown very clearly that when people handwrite things, when they manipulate things, when they do something with their hands or with their senses, they are much more likely to learn and internalize knowledge than if they just see it or if they just type it or if they just cut and paste. Okay, so this is for your benefit so that you have this information. It's part of the course. Make sure you follow that instruction. That's extremely important. Okay, then you watch all these things. You fill out these numbers, the W, X, Y, and Z. You'll use them often throughout the course. Every study guide has its own set of W, X, Y, and Z, and you might use them for scientific calculations or numerical purposes, but you got to do this in every single one. Okay, then you take notes on the lectures. Now, notice that I've written here a 20 to 40 word long answer. Does that mean you should just write 10 words on there and be done and walk away? No, right? Write 20 to 40. If you want to write 50, 60, 70, fine, go ahead. I don't mind. Feel free to put it on a different piece of paper. Feel free to write really small, squeeze it all in. If that's really cool, that'll help you, great. But what we should be doing is to be writing notes for the class. And then you fill in on the study guides the key points for the classes so that you can go back and refer to the key points, whereas your notes got all the details in it as you see fit. Okay, so make sure to follow those instructions. That's how you get credit for these courses. If you fill in 10 words instead of 20, well, probably won't get full credit for the study guides, right? That makes sense. Now, notice you get to watch all these other things. Videos of different kinds. Remember I was telling you about high production value videos? Here's your opportunity to watch them, things that have been read before and things that have been done. Okay, first, there's the OpenStax College Physics online textbook that I want you to know about. And then there's the Physics in Motion stuff. And then the Diana's Intro Physics class. These are all things that you should be aware of. Let me show you them on these tabs. College Physics, okay, is a book that was put together by professors who have written textbooks before, but they did this so that you could get it for free. They worked with the OpenStax Foundation, which is based at Rice University in Houston, Texas. And what they've done is made full, high-level, high-quality textbooks that are online educational resources free of charge to students. If you want to make a donation, great. If you want to get involved in buying hard copies, feel free. But you can otherwise just use it and learn from it. And they just want to give it to you. They just want you to learn it. Isn't that sweet? Yes, and that's why we use it, okay? And if you're going to look at it, you can see the table of contents. You can click on that. I'll show you all these kinds of things. So for example, here's table of contents. Here, there's chapter 2, kinematics, stuff about things moving back and forth and how fast they speed up and how fast they slow down and how you represent them in graphs. And then you have Newton's laws of motion. Our lectures don't follow all these chapters in line, but we kind of move around and we kind of weave back and forth. And the same is true for the labs. Sometimes you'll learn something in the lab that is not quite synced up with the lecture or not quite synced up with the textbook. Don't worry. Eventually, it all kind of weaves together and balances out, and it's all part of the learning process. Okay, so don't panic about that, but find ways to make bridges and connections. At some point later on in the future, it might be like, oh, that's what I was doing in the lab. Or it might be something like, oh, this I learned in lecture a couple of weeks ago. Now I see how it's working out in the lab. All of it is tied together. So enjoy that aspect of the very different components of this course and how you're learning from them. Does that make sense? Okay, so the textbook is very useful. And then in addition, I was showing you some of those other web pages, right? These sites that have videos with very high production values. All right, this is Georgia Public Radio, the GPB folks. They got a whole thing about physics, scientific notation, significant figures. A lot of the stuff is designed for high school students, but much of it is also relatable to our physics class. So don't worry about the fact that it says high school or college or whatever. Just learn the processes, learn the concepts, because that's what they're there for. Okay, and they're basically interchangeable from one to the other. So enjoy the physics in motion stuff. It's great stuff. I mean, read, like I said, high production value. They visit race tracks and they throw stuff and they've got animation, and this is awesome. Now, another second group that we use a lot of is this Diana's Intro Physics. This person, Diana Cowan, I think she grew up in Hawaii, and then she went to MIT and did physics, and she loved it. And she decided that for her career, she would do connections with people about cool physics, doing it both sort of by textbook ways about things like how you make calculations and how the equations work together and how they all fit, together with cool demonstrations and ideas about how all of it comes together to create this amazing set of rules that govern our world and our universe. So Diana's intro physics class, again, although it has sort of high school AP physics written all over it, it's really about the same material that you're learning in this class, more or less. And we're going to pick and choose the parts that are most relevant. And then finally, many of you have used this before and just watched this, called Crash Course, right? The Green brothers, John and Hank, were involved in creating Crash Course a long, long time ago. It's since expanded quite a bit. Crash Course Physics is narrated or hosted by Dr. Shini Samara. She is really good at this stuff. The point is that if you want to learn additional concepts with fun animations and high-level production values and things like that, this is the place to go. So you'll see some of the stuff that we're doing in the study guides will have to do with seeing these different things. Okay, so you've got video assignment for lecture 1. After you do these things, right? Remember, handwrite all your answers, follow the word guides, read the instructions extremely carefully. If you read the instructions and you follow them, that's how you get good grades in the class. Remember, it is your effort, it is your completion, it is the thing you put in that matters to me more than the correct answer. Keep that in mind, okay? And then the video assignment for lecture 1 is indeed the honor statement in a video. Make a short video and email it to me. And I'll show you where to send the emails and things like that, right? Follow the instructions given elsewhere in the course material. There's a specific email address that you send all the stuff to. So that's what you're going to be sending to. All right. And it's really important that you have to send it in, because this is the way that the college keeps track, because it's an asynchronous class, of whether or not you're actually taking the course or not, right? If you're not participating in it, then you'll get administratively dropped. So it's really important for you to do this and to pay attention to all the stuff in Blackboard. And then starting with lecture 2, make sure to read through the study guide before you do the lecture video, right? Watch the lecture video, but first see all the different things that you're doing. All these cool things: Crash Course Philosophy, Science for Class videos. See what those things mean, right? And then lecture 3 is its own thing about people, scientific unit conversions, and so on and so on. Each of these study guides is about 2 pages long, and it's got different pieces of it that you can take a look and do. And they have specific due dates. And I really, really re-emphasize to you all, please get them done on time, get them done early, follow the instructions, turn them in piece by piece, pace yourself through the class, all right, and do them well. Do them with good timing, and you will be glad you did. All right, you, like I said, might not become super physics person, but that's okay. If you know this physics, it will benefit you, I promise. A lot of it is just that common sense, but turned into something that you can then hold, something that you can then use, right? From common sense stuff to actual full-fledged application. And it is because of that that we have things like computers and cell phones and cars and buildings and air conditioning and heating and motors and all these things that make our modern society tick, right? Not to mention heart valves, or defibrillators, or eyeglasses, or hearing aids. All these kinds of things, all are applications of physics. Hang on a second while I cough a second. Thank you, I'm back. You didn't need to hear me cough, so I just coughed and like drank some water, and we're all good. Anyway, bottom line is, I am so happy that you're in this class. There's so much to learn, so many neat things. Watch the Blackboard. Be very careful. When you see emails from the Blackboard account for the course, take them seriously. Every paragraph, every sentence should have valuable, useful information. Don't skip them. When you see something from the lecture professor, pay attention to it. Do that stuff as the lecture professor suggests. If you see something from the recitation professor, follow that professor's recommendation. If you see something from the lab professor, do that very carefully, because again, if you don't pass the lab section, you don't pass the course at all, right? These are all the different things that you do, but if you do them, then you will take that wonderful leg up, and you will understand, in my opinion, I have a strong feeling that you will know why you took this physics class. And when you have those skills and those abilities, even if you're not a master of them, if you understand them, if you know that they're there, that's the first step as you go forward in your career, whatever it may be, that gives you power, that gives you knowledge, that gives you a sense of understanding the universe. Who doesn't want that, right? How does the universe work? How does the world work? How does the human body work? Physics. All right, so that's it for this lecture. I hope you, again, go back and take a look at the first lecture study guide, figure it out, fill it out properly, and then go on to study guide 2 and 3 and 4 and so on. Follow the instructions that are given on the Blackboard notification, and I can't wait to meet you in person. I hope we'll be able to talk at some point on campus. Maybe not right now, hopefully in the future. It'll be great. All right, thanks. Talk to you again really soon, okay? Thanks again. Really appreciate it. Talk to you in lecture 2. See ya. Bye.